In this video, we're going to solve another practice, question number 5 from chapter 11, hotel room allocation. So here I have the question. We have a hotel with 2 types of rooms and 3 rental classes. So they have 2 types of rooms, limited number of rooms from each type, and then they want to allocate it to different classes of rentals, different classes of customers. So they have super savers, they have deluxe rental class, and they have business rental class. In this table, we have the profit per night for each type of room and rental class. So let's say if they allocate one room of type 1 to super saver, they're going to make a profit, a net profit of $30. But that's given that they can rent it. There should be a demand for that, right? Given that there is a demand, if they succeed to rent a room type 1 to super saver class, they're going to make a profit of $30. So now, and then we have some details on room type 1 and room type 2. Room type 2 are usually more expensive for the hotel. And so now we want to formulate a linear programming model that maximizes the profit and answer this question: how do we allocate different rooms to different classes? All right. How do we rent actually based on the demand, based on the number of rooms that we have available? They know the demand forecast for a particular night is 130 rentals in Super Saver, 130, 60 in the deluxe class, and 50 in the business class. The round 3 hotel has 100 type 1, 100 rooms of type 1 and 120 type 2 rooms. So we now know the limited number of rooms. We know the exact number of rooms that they have available. And we also know the number of people that are going to rent the rooms, right? So now it's similar to what we had before, supply and demand in production planning examples. Except that here demand is more than supply. We need to, we can't we can actually allocate more than what we have available, but at the same time, we should not over allocate. We should respect the demand. We don't probably need to satisfy the overall demand, but we should make sure that we do not over allocate to a certain class, to a certain rental class. So part A, formulate and solve a linear program to determine how many reservations to accept in each rental class and how the reservations should be allocated to room types. So first thing first, let's just formulate the problem. Mathematical formulation, the first thing that we need to do would be to understand what our decision variables, and to determine what our decision variables are going to be. So we have 100 of room type 1 and 120 type 2 rooms. And the question that we want to answer is how to allocate these rooms to different classes. So I would call this as my decision variables. The number of room type 1 to be allocated to Super Saver, that would be one variable, one decision to make. The number of type 1 room to be allocated to Deluxe, and so on. And the last one will be the number of type 2 rooms allocated to Business Rental class. Number of room type I to be allocated to rental class J. And I'm going to call it X, Xij. The number of rooms, room type rooms, with number of rooms of type 1i to be allocated to rental class J, Xij. That is our decision variables. We have, we can't allocate type 1 rooms, type 1 to business rental class. As you can see here, it's impossible to allocate. So in total, we have 5 decision variables, right? 5 decision variables. Like X1, 3 is not working, is impossible. So I'm going to consider this to be five decision variables. Next thing, objective function. The objective function is going to be profit, the total profit. And of course, we want to maximize it. So I just put it right back here. Maybe before that, maximization of total profit. And the total profit is going to be, so for each room that you, each room type 1 that you allocate to super saver rental class, you're going to make $30 in profit. So now if you allocate X11 or X1S, if you want to call it X1S, X1D, X1B, that's probably a better way to call them, X2S, X2D, X2B, then the profit function is going to be 30 X1S plus 35 X1B, and so on. So 30 X1S, or let me just add this. Plus 35 X1D plus, and then nothing for the business class, type 1 and business class, plus 20 X2 super saver S, and so on. So that's the objective function. And then we have constraints. And then the constraints that we have here are the demand constraints, right? So if we want the profit to be realized, we have to make sure that, let's say, X1S is not going beyond the actual demand for that group for 130. So you can't really allocate more than 130 to super saver class. If you do that, then anything above 130 on this one, it's not gonna take. The profit for that is gonna be 0. So this 30 profit per unit is as long as the X1S plus X2S, the sum of these two is less than 130, because beyond that, there won't be any customer asking for super saver class. You have only 130 people asking for super saver. So if X1S and X2S, if these are the number of rooms allocated to super saver. If they're more than 130, you will end up not being able to rent them, and the profit, the net profit for those extra rooms allocated to super saver is going to be 0. So it's easier just to make sure that it doesn't go. These two, the sum of X1S and the sum of X1S and X2S should not go over 130, which is the demand for the super saver class. All right. So we have two sets of constraints. We have a limited number of rooms, room type 1, and then we have only 100. So for the number of room type 1 that you can allocate would be X1, X1S plus X1D, and then nothing to the business class should be less than or equal to 130. Sorry, less than or equal to 100 type 1. So we have 100 type 1 rooms and 120 100 room type 2 X2S plus X2S plus X2D plus X2B. These are the total number of room type 2 that are allocated to different classes. X2S plus X2D plus X2B should be less than or equal to 120. All right. So the number of rooms, so we have a capacity limit. We can't allocate more than 100 room type 1 because we don't have more than 100 units of type 1 room. And then same thing for room type 2. So that's the room availability. And then we have a second group of constraints, which would be the demand constraint. Oops, sorry. So this was room supply constraints or room availability constraint, and then demand constraints for each group. And then business. So for Super Saver, the number of rooms allocated to Super Saver should not be more than 130, because if it goes, like I said, if it goes above 130, the profit of 30 will not be applied to extra items. The profit will be 0 for any room allocated to Super Saver after 130 units. All right, so X1S plus X1S, X2S. So the sum of X1S and X2S would be the total number of rooms available for Super Saver customers. So that should not be, that should be less than 130. X1D plus X2D should be less than or equal to 60. 60 people are interested in deluxe suites or deluxe rooms. And then for business people, for business class, we have only type 2 rooms. So X2B should be less than or equal to, we have 50 people in business class, 50 demand in the business class. So the number of rooms allocated to business class should be less than or equal to 50. All right, 50, 60, and 130. So that is our formulation. And then we have, of course, the non-negativity. We have Xij greater than or equal to 0. change this X, I, J. All right. So now that was our formulation. Let's now develop our spreadsheet model. We have, again, decision variables. And like I said, we have 5 decision variables. So we have room, type 1, type 2. We have super saver, deluxe, and business. So these are my decision variables, except for this one, which is not available. I just changed that one back to no field. All right, so these are my decision variables, 5 highlighted cells. And for this one, you can just put 0, for example. It doesn't really matter. We're not going to include it as our changing variables when we're putting it in our setup. All right. Objective function is going to be the profit. I haven't put my parameters. Let me just add the parameters somewhere on the sheet. So it's going to be profit per unit, per profit per room. And then we have $30, $20, 35, 30, and 40. And also, let me just write down in the list of parameters that we're going to use the demand for each type. We have 100, 30, 60, and 50. And let me also write down the availability of rooms. We have 100 and 100 type 1 and 120 type 2. All right, and these numbers are dollar values. And these numbers are number of rooms, all right? And I think that's it, yes. So our objective function now, objective, which is the profit, is going to be some product of array. I just go ahead and I'm including this one too, the last one, which is empty. It really doesn't matter because at the end of the day, when I'm putting my changing variables in the solver, I'm not going to include this one. But and because of that, and it's just shorter, just to use some product once without this one. So that's perfectly fine. If you want to be sure that this will not take any values, even if you want to include it in your solver as your decision variable, you can put a very negative number, a very large number, I mean a very, very small number, a very negative number, just so to make sure that this will not, your objective function is a maximization. And if you put a negative number, a negative number, significantly negative number, it's gonna make sure that this will be always 0. I mean, right? So it doesn't allow this one to take any positive value. It's just force it to be 0. But even with 0, it's not gonna be, because all other numbers are positive. This is still much less than the other. So that's good. And then objective function is the profit function. And then we have the supply and demand constraint, availability of room constraints and demand constraints. So for demand, for availability, let's put it first, is to availability. So for room type 1 and type 2, the number of rooms that are allocated to the number of type 1 rooms that are allocated would be the sum of these two. The number of type 2 rooms that are allocated would be the sum of these three. All right. And then we want these to be less than or equal to 100 and 120. All right. So that's the availability of the rooms. And then we have, so that's the first set of constraints. And then we're going to write down the second set of constraints. All right. The second set would be about the demand for each rental class. So that's okay. Demand for each rental class. So for Super Saver, the number of, we just said here, the demand constraints. The number of rooms allocated to each rental class should be less than or equal to the maximum demand for that type, for that class of customers, right? So for Super Savers, the number of rooms that are allocated to this class would be the sum of type 1 and type 2. And that should be less than or equal to 130. That's the demand, right? 130. So yes, and then same thing for deluxe. It's going to be sum of type 2 and type 1 and type 2 here. If I just drag my formula to the right, it's going to take care of those for me. So except for the last one, which has to be, I don't need to put sum of these two. It's enough to just put Q24, all right, which is the number of type 2 rooms allocated to business class. That should be less than or equal to 50. All right, so I think we now have everything ready to go ahead and go to the solver. Let me just make sure that, yes. So we have the decision variables, we have the objective function, and then we have the list of the constraints. So now what I'm going to do, I'm going to go ahead and go to the solver and make sure to set up all these parameters in our solver. So we want to maximize the profit, the total profit, by changing these 5 decision variables, and I'm going to separate them by comma. I said I'm not going to include this one because we know it's impossible, and I'm not going to put it here. But even if we do, it's not going to hurt anything. It's not going to change anything because here we have 0, and 0 is considerably low compared to other profit contributions, right? Compared to other figures that we have here. So that's good. So subject to the constraints. What are my constraints? I have 5 of them. I have room availability. The number of rooms allocated should be less than or equal to the number of rooms available. The number of rooms allocated to each rental class should be less than or equal to the maximum demand for that class. And that's it. And then making sure that my solving method is simplex linear programming and then non-negativity constraints. I believe everything is set up, so let's go ahead and try it. I'm just going to add the answer and sensitivity report because we may need to get to the sensitivity report for answering some of the follow-up questions for the next part of this question. So, okay. So the solver was able to find a solution, a feasible, optimal solution for this linear programming problem. So let's take a look at our answer. So we see that of 100 type 1 room that we had, all of them are allocated to Super Saver class. And then we, out of 120 available type 2 rooms, 10 to Super Saver, 60 to Deluxe, and 50 to Business class. All right. So we are using everything that we have available. And then the total profit that we can make, the maximum profit that we can make is $7,000. And then we are satisfying the demand for business customers for business class and deluxe class. Those are believed to be the most profitable classes. And then for the Super Saver class, we are we're not using, actually we're not pushing up to the level of the maximum demand. We have still 20 slag to go with, right? All right. So that's the answer. Let me just go back to the question real quick. Formulate and solve a linear program to determine how many reservations to accept in each rental class and how the reservations to be allocated to room type. So now we have the allocation, and we also know that in each rental class, how many rooms should be allocated. The answer to that is here, the left-hand side of demand constraint. So the number of rooms allocated to Super Saver is the sum of these two, 110, 0 and 60 for Deluxe and 50 for Business. All right, part B. For the solution in part A, how many reservations can be accommodated in each rental class? Is the demand for any rental class not satisfied? Is the demand not satisfied for any class? We just said that the demand for Super Saver is not 100% satisfied. So we have a demand of 130, but we have allocated 110 rooms to that rental class. So we have still 20 unsatisfied demand for this class. All right, so that's the slack for this constraint. With a little work, an unused office area could be converted to a rental room if the conversion cost is the same for both types of room. Would you recommend converting the office to a type 1 or a type 2 room, and why? So this question asks if, let's say, the availability of room, the current availability is 100 units of type 1 room and 120 units of type 2 rooms. Now the question asks, we can add either of these two numbers, either of these two figures by 1 unit. Now, what is your preference? If, let's say, if we increase this to 101, or if we increase the number of type 2 rooms to 121 units, which one do you think is a better decision? Which one do you think is a better addition? So how do we answer that? How do we evaluate our decision in this case? At the end of the day, whatever we do in this question should be evaluated in terms of profit. So whichever change in our set of parameter that leads to the maximum change in the objective function in the profit would be considered to be a better change in the set of parameters. And in this case, uh, we just need to look at the rate of change in the objective function with respect to the right-hand side vector and compare the shadow price. That's the answer that we're looking for. The shadow price of these two, and see which one has a larger shadow price. Because shadow price was what? Shadow price was change in objective function, which in this case is profit, with respect to a unit increase in right-hand side vector, RHS. All right, so that's the definition of shadow price. And now if I go back to my sensitivity report here and look at my availability type 1 and type 2 rooms, the availability constraint, the names is not coming up perfectly. You may want to rename these. So type 1, why is it called SS? Type 1, it's because of this, but I'm going to call that type 1 availability, type 2 availability. So currently the right-hand side, sides are 120, but then we have the shadow price that are 30 for type 1 and 20 for type 2, which means that if you increase this 100 by 1 unit to 101, your objective function is going to go up from 7,000 to 7,030. Or if you change that 120 for the maximum availability for type 2 room from 120 to 121, your profit is going to go up by 20 units. So when we compare these shadow price, type 1, if you have the option, a new conversion or a new addition, type 1 room is more profitable. If you have the option of addition, if you have the option of conversion, a new addition of type 1 room is more profitable. And the end, I mean, how do you know that? By looking at the shadow prices. And whichever has a larger shadow price in this case would be a better addition, a better investment, right? Which would be type 1. So going back to the question, and then why? Because it has more impact, better impact on the profit. Could the linear programming model be modified to plan for the allocation of rental demand for the next night? What information would be needed and how would the model change? So you just need to look at your model and see, usually if you set up the model well, if you set it up in a right format, in a right way, you don't really need to change a lot. At least you don't need to change your solver setup. But what you need to change and what you need to be really careful about would be these numbers, all the set of the parameters that you use in formulation of your problem. From tonight until tomorrow night, the availability of rooms probably is not going to change, right? So you're not going to really convert another room, let's say overnight, you're not going to see a major change in the availability, but the demand might be really subject to major changes from a night to another night, right? So you want to confirm these numbers. You want to also confirm the pricing. Again, price from a night to another night. If it's, let's say, if tonight is weekend, tomorrow night it's not, then the price might be drastically different, right? You just want to confirm the prices and also the demand. Also, if the availability is subject to change from a night to another night, availability of rooms, you may want to also check that. Once you have these ready, if you don't have a new rental class, if you don't have a new room type, right? So these are some things that are not going to change from a night to another night usually. But these numbers, all these numbers may change from a night to another night. So you just want to confirm these numbers, come up with a better forecast for the next night, and then run the model again and see what answer you get.